Okay, this is chapter 1 glossary. This is a very important part of our training since we're going to see concepts from backup. Retention is the time frame within the backup data cannot be overwritten or erased from backup volumes, unless of course there is a human intervention. So backups start. After the backup is done, and we have to configure something in Bacula to tell when the retention is going to start, the retention starts to run, to count, to be accounted. It's a time. You can set it in hours, days, months. Okay, it's a time period. And after that, during this time frame, this backup data, this specific backup data, cannot be erased. Okay, this is the most important thing for our backup since it is the guarantee that you have the backup of the data to restore into that the time period. Okay, and after the time period is done, which is the expiration of these volumes, normally the backup tool is configured to recycle these volumes. In other words, allow the backup tool to overwrite this volume that is not into the retention time frame anymore. Okay, it's important to say that the backup tool will only overwrite this expired volume if storage space is needed to new backup jobs. Okay, so an expired volume unnecessarily it's a volume that you can't restore the job. Okay, job, it's the backup to operational unit which has a finite duration. It's the backup to command which tells the clients to send the data to the storage and effectively do the backup, or vice versa, do the restore. So there are mostly backup jobs, write, and restore jobs that are read operations. There are, however, another job types that Bacula provides. For example, copy, which is copy already done backup to another storage, another place, another device, and migration, which is the same but discards the original data. Verification and deduplication backup. Purge is the act of allowing the backup tool to overwrite a volume. Okay, it's when the volume enters the retention and then gets expired, and then the backup tool needs to rewrite it. Then if well configured to work automatically, it will purge the volume, recycle, which is delete all the associated indexes in the Bacula database from that volume, and then the backup can be overwritten. It is usually executed automatically when the backup volume is expired and another backup job needs writing storage space. Volume is the logical division where the backup tool can store the backup data of different servers in a byte sequence. It's always a byte sequence. For disk backups, a volume is a file, and a disk used for backup can contain many volumes or files. This is the great difference. This is a big thing here. The backup disk, hard disk, can contain several volumes since it's a randomic access device. So indeed it's advisable to have many volumes in the same disk, since the purge, the recycle of those volumes, it's an atomic transaction. Or you recycle all the volume and then the backup tool can discard all data on it, or you don't recycle at all and you preserve your data. So in order to maximize, to better use this backup in disk, you should have many volumes on it. Unfortunately, for magnetic tapes, which are sequential access device, the volume is the media itself. You can only have one volume per tape, per magnetic tape. Okay? Pool. Pool is a group of volumes that should have the same properties. For example, volume retention. The best analogy that I used to teach about the volume pools, the backup pools, is the group of users on a directory service software. Okay, it's the same thing. The objects that are into a group, they should receive the inherit the permit the attributes from the group. Okay. A backup job is submitted to a pool and can only be written on volumes that belong to that pool. That's another important thing. When I submit a backup job, I have to have writable volumes in the same pool which the job is submitted. There is no use have writable volumes in another pools that are not the submitted backup, the one that you submitted the backup. And there's an implicit rule from Bacula. All volumes in a pool should use the same storage. So if you have more than one device, storage device, for example disks and tape library, you should have at least one pool for volumes in disk, one pool for volumes in the tape library. This is the diagram from these concepts that I just showed you. Okay, the volume, it holds the jobs. I can make many jobs from different servers, Linux servers, Windows servers on it. It's a byte sequence. Okay. Volumes should have a pool. I can have 1, 2, 3, how many pools I must desire. Normally these pools, if when I use more than one pool, I use with different retentions. And here an example of a second pool for magnetic tapes volumes. Catalog. Catalog is that database that Bacula needs. All backup tool needs a database to store the indexes of the data which it is writing on the backup volume, on the tape, on the disk. Okay, and this is another great thing of Bacula. Bacula, I think it's the only multi-database backup tool. It can store its catalog in MySQL, Postgres, SQLite, and like I said, it contains the indexes of all backuped files. Okay, this is very important because the byte sequences in disk volumes and in tape volumes, they don't have a file system, they don't have the index there. So the only way to know where a specific file is stored, a job data is stored, it's through the backup catalog. It allows to list backup contents and to restore one or a few files from the job. It provides association between the backup jobs and the volumes that contains that backup media, that backup data. This one I already told you, and this it's the same diagram, but you should note that all this information, the information is about pool, about devices, about volumes, about jobs, they are stored in the Bacula database. Okay, so the database from Bacula is the heart of your backup management. Okay. File set. File set is the list of files or folders that will be copied in the backup jobs that uses. You can include or exclude files from a file set, and the backup tool will copy these folders, for an example, recursively. Okay, so if I include the root for a Bacula for a Linux operational system, I should probably want to exclude the slash tnp slash p proc and another folders that are not important that are on the root uh, folder directory from Linux. Okay, so it's always the same for any backup tool, or you include folders or you exclude them for the backup list. Okay. Backup policy, it's not necessarily a backup tool concept, but it's very important. It's a formal corporate document that outlines data retentions, periodicity, and other security aspects of the backup service. If you don't have the data retentions for how much you should retain that backup data, it's very hard to plan a backup system. Okay, so this is a very important thing. And in this document, usually have effects from operational level agreements for business needings. Okay, so this is very important to have in the company. GFS, grandfather father son backup. It's the mostly used backup data rotation scheme worldwide. It uses different backup retentions, most commonly distributed among daily, weekly, and monthly backups. This is a very economic way of doing backups. Okay, if you have a monovolume backup with only 20, approximately 20 volumes of backup, you can have a retention for 1 year using incrementals or differentials and full backups at the weekends. And so this is the strategy that we'll be using in our training. At least on and off-site backup, data is stored in the same building of the originals or not. Like I said before, it's a risk cost relation. Okay, sometimes the biggest example of it on an off-site backup is the World Trade Center. That incident that occurred in 11 September 11, and the backup from one tower, the backup data from one tower was stored in another tower. So when the two towers failed, all the data from originals and backups are lost. So it's a thing to think. The ISO recommendations tells that the backup data should remain in a building at least 15 kilometers at the original. Most of time it's the 15 kilometers because it's the range of impacts of 1 megaton bomb. Okay, this is why the motive of it, the reason for it. We know that most of time we can't. That's very expensive to have backup from that distance from the original data, but it is something to consider. Some companies, in order to avoid this risk, they used anti-flame safes. Okay, and it's a way to preserve backup data also. And that's it.